Hi everybody, today we will be moving on in Unit 2. We're going to do the second half of Unit 2, which will focus on graphing quadratics, but also we'll start applying our skills with solving. So this first section, 2.6, is all about graphing quadratics in vertex form and in standard form. Now we haven't really talked about these different forms. Vertex form is this guy right here, y equals a times x minus h squared plus k. Think about that's a quadratic. If we FOIL out x minus h times x minus h, we get ax squared, which makes it a quadratic. Okay, this form should sound familiar because this is the form we used when we were graphing parent functions and their transformations. If you remember, h is a shift left or right. Remember the trick about h is that we have to switch the sign. So if we subtract h, that's actually moving in the positive direction, which would be to the right. So subtraction means right, addition left. So you switch the sign. K is a shift up or down. Up with plus, down with minus. A is either a stretch or a compress. Remember, if it's greater than 1, it's a stretch. If it's a fraction less than 1, it's a compression. And negative a is a reflection over the x-axis. Okay, now we have to start by reviewing those parent function points for every quadratic. So if we have f of x equals x squared, remember our starting x values are always -2, -1, 0, 1, and 2. When I square -2, that's basically saying -2 times -2, which is +4. -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. So -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. Okay, that's the parent function. Now remember, domain and range. If we have our ends going in either direction, both on the left and the right, our domain runs all the way from -infinity to +infinity because those are our x values. Our range, however, are our y values. In this case, our range starts here at 0 and goes up to +infinity from there. Okay, that's just a quick review. So now let's do a few. In this case, x plus 1 squared minus 2. We have two transformations here, this plus 1 and the minus 2. Because the plus 1 is in the parentheses, that's a left or right, and because it's positive, we switch the side or the sign and we go left 1. Then in the back, minus 2 tells me I'm going to go down 2. So now I start with my regular table. Okay, oops, it didn't copy. And then I'm going to move each of those points to the left 1 and down 2. So -2, 4 will go left 1, down 2. -1, 1, left 1, down 2. 0, 0, left 1, down 2, 1, 1, 2, 4. And there we go. Close enough. Okay, in this case, our domain, -infinity to +infinity, you'll find that that's always the case for every single quadratic. Okay, then the range here starts down at -2 and goes up to +infinity. Okay, in this case, we have a reflection and a stretch by 2. Then we go up by 4. Okay, so when I paste my table, Now remember, anytime we reflect, stretch, or compress, we're going to multiply all those y's by that value. So in this case, we're going to multiply our y's by -2. Okay, so we keep our x's the same, so now we're going to have -8, -2, 0, -2, -8. Then we're going to bump them all up by 4. So -2, -8 would go down there, but then we go up 1, 2, 3, 4 to -4. -1, -2. Now we go up 4 to +2. 0, 0, up 4. 1, -2, up 4. And 2, -8 would go up here to -4. Okay, now in this case, our domain is still negative to positive infinity, but our range has switched now to be from down at the bottom, so negative infinity up to +4 with a bracket there at +4 because our y values end at +4. Okay, so that's vertex form. The point there is that the vertex is right here. It's the point 4 or 0, 4. So picture that 4 came from our positive point. Over here, our vertex is here. It's the point -1, -2. 1, -2. You switch that sign, so technically it's -1. That's why that is called vertex form. Now we're going to move on to standard form. We know that the standard form of a quadratic is ax squared plus bx plus c. And in order to graph the graph of a standard form quadratic, we have to first find the axis of symmetry, which is the vertical line x equals -b over 2a. Okay, once we know that, we can find the vertex by plugging x into the equation. So if we solve for the x value of our quadratic using this -b over 2a formula, then we can plug that in to our equation in order to find the y value of the vertex. Okay, the y-intercept is when x equals 0, or it's just the c value. So that's another option that we can use when we're graphing. Okay, so here our graph says 2x squared plus 4x minus 3. So the axis of symmetry in this case is the point, or is the value of -b, so -4 over 2a, where a is 2. Well, this turns into -4 over 4, which is -1. Okay, now we know that's an x value. We know that'll be over here at -1. Okay, that tells me that the x value of my vertex is -1. Then in order to find the y value, I am going to plug -1 in for x. So y equals 2 times -1 squared plus 4 times -1 minus 3. Okay, now I'm going to pull up Desmos. Oops, sorry guys. What is happening? There we go. So here I'm going to say 2 times -1 squared plus 4 times -1 minus 3 is -5. So that tells me the y point in my vertex is -5. So now I can plot that vertex point, -1, -1, 2, 3, 4, 5. Now we find the y-intercept. The y-intercept is when we plug in 0 for our x's. But ultimately, it's also just equal to that c value in the back, which will be -3. So now I can plot a point down here at -3. Okay, that gives me one branch of my quadratic. Now remember, a quadratic is symmetrical. So if this has this point right here at -3 will be matched right here 1 unit away from that axis of symmetry. Okay, that'll create this symmetric curve, and there's our graph. Our domain, as always, is -infinity to +infinity, and our range, in this case, starts down here at our -5 and goes up from there. So we don't need parentheses there, we need a bracket at -5 and up to +infinity. Okay, here's our second one. Y equals -x squared plus 2x plus 6. So -b over 2a will be -2 over 2 times -1, which will be -2 over -2. So x equals +1. So here's our axis of symmetry. Now to find the vertex, we know the x value in that vertex is 1. We need y. Okay. Remember, you keep that negative outside of the parentheses with the 1. So we would type this in as -1 squared plus 2 times 1 plus 6, and we get 7. So 1, then 1, 2, 3, 4, 5, 6, 7. Our y-intercept is that last c value, which is 6. So it goes right here at +6. Now remember, that's one branch. We have to hop over and reflect that point over the axis of symmetry to find our next branch. Okay, domain as always, -infinity to +infinity, but in this case our range starts up here at +7. Well, actually no, starts down at -infinity and ends at +7. That's our highest point. That's a maximum. Okay? Now just to review, if we look at this graph in number 2, that guy would have 2 real solutions. 1, 2. It has a vertex here at the point 1, 7, and that's a maximum. This guy would also have 2 real solutions. 1, 2, and its vertex is over here at -1, -5, but it's a minimum. Okay? 2 real solutions and 2 real solutions. So all of these graphs that we looked at in our notes today had 2 real solutions. Today for practice, you're going to do an exit ticket. You're going to do 2 vertex form graphs and 2 standard form graphs. Okay? See what you can do. Submit this and I'll grade it, and I will see you guys tomorrow.